We are looking at number 27 in the review assignment for Chapter 5, Proof Geometry. So we have our little triangle here, our ABC. I know that the tiny little triangle up here at the top is isosceles. I know that I've got some midpoints here, so that D is a midpoint and E is a midpoint. And then I want to end up proving that this side equals this side, so DK equals EK. And I also want to prove that triangle AMB ends up being isosceles. And there's one more bit of information, and that's that they did tell me CD and CE are the same. So let's take a look together. All right, let's start with trying to prove this top piece. I want to end up proving DK and EK are the same. Okay, stuff I know. I know this top triangle is isosceles. I also know CD and CE are the same. When I start looking at this, I start seeing some overlapping triangles. So let's just draw some of those overlapping triangles over here on the side. I've got this triangle, and that's triangle DCG, and then I can go the other way, and I've got triangle C, excuse the handwriting here, I don't have a stylus with me at this moment, CFE. Looking at those triangles, I know side CD and side CE are the same. I know that CG and CF are the same. I also know that they both share angle C, which means I basically have side angle side congruence, right? And if that's the case, then that means if I look at angle 1 and angle 2 here, and then I put them in here, I've got angle 1 and angle 2. I know angle 1 and angle 2 are congruent to each other. Corresponding parts of congruent figures are congruent. Alright, so now let's look at these tiny little triangles in here. I want those triangles. If I can prove those triangles congruent, then I can prove their sides are congruent. Well, I already have angle 1 and angle 2. I also have some vertical angles in here, right? And now I simply have to show that DF and GE are the same, and I'd have angle side. Now we're going to show that FD and GE are the same, and I already know, let's say, that CF, this piece here, is the same as CE, this piece here. And I know the part CF and CG are the same. So if we build out this side saying CF plus FD is the whole thing, CG plus GE is the whole thing, that's our definition of betweenness, then you can start getting some congruent segments and subtract it out. And then you've got angle side for those triangles. Alright, let's take a look now at trying to show this bottom piece, that this bottom triangle is isosceles. Let's go ahead and here. Alright, so this is my triangle I want to end up looking at. I know I know D is a midpoint, I know E is a midpoint. That means this side right here, this side right here are the same. I also know that this piece and this piece are the same. I also know that this whole top segment equals this whole top segment, and that's pretty much what I need. So let's start by looking at this big bottom triangle down here, ADB. And if I look at triangle ADB, here's A, here's D, here's B, and then I look at the triangle I want to prove it congruent with, which would be A, E, B. I can show that side AD is equal to side EB. Just like we did up top for the previous one, I know that D is a midpoint, E is a midpoint. I know that this piece and this piece are the same, so I should be able to just show a congruence between all four of these line segments, AD, DC, CE, EB. That shouldn't be too difficult to do. Once I do that, I can then say, hey, look, I've got congruent sides here. I also know that AB is congruent to itself through the reflexive property. And now I simply have to show that angle A and angle B are the same. Well, I know that this is an isosceles triangle then, right? I mean, if I proved that this side equals this side, that means I've got base angles equal. That means angle A and angle B are the same. So I've got triangles congruent through side angle side. And if that's the case, if I look in here at my small angles, angle 3 and angle 4, that's angle 4, that's angle 3. I now have angle 3 is congruent to angle 4 through CP/CTC, and that means then I've got an isosceles triangle by the converse of the isosceles triangle theorem.